They're both pretty reliable in my experience.
Oh, really? I've gone ahead and started the recording to the computer. I'll figure out where to put that next. I don't want to figure it out right now. But to your question, Alexa was one of the biggest contenders in wanting to talk about that, but he is probably not going to join. I mean, I'll message him, but then if we know that Mernal's not going to be on the call, the only other person would be Crosby.
Right, and one of the other person, Trevor King, I think.
Trevor, I don't think he's participating.
Okay.
Trevor what? Trevor King is.
Yeah. Because he was the one who was suggesting an alternative to pre-start hooks, I think. So maybe I can give some context on how we've integrated the GPU stack at NVIDIA, and then maybe that is probably something that will help understand a bit more where we're at right now and what we would like to happen in general. So you can maybe start with the challenges that we have at NVIDIA. I think the driver stack that we have is a bit more complicated than just exposing a device node inside the container. We need to mount a number of libraries from the problems that we have are related to the fact that we have a software stack that is pretty large and complex, and some of the guarantees that we provide is for, or in terms of when you are building a CUDA application. So a CUDA application is an application that is going to run code on your GPU. And the general consensus of when you are building, or the general way we encourage people when you are building a CUDA application is you are going to dynamically link against a number of SO files. So for example, libcuda. The way that we deliver some of these libraries, most actually CUDA applications are going to link against 10, 15 .so files. And the way that we deliver these applications, this libcuda.so, is that they're tightly coupled with the driver version, meaning that when you have a driver version that is, for example, 400.00, we don't use Semver for the driver versions. You are also going to install libcuda.so.400.00. And when your binary dynamically links against libcuda.so, and when you, so suppose you were to actually ship your binary with this libcuda.so.400.00 on a different machine that had a different driver version, this would not work. Meaning that you would need, if you want to have your application to be portable from one machine to another, you need to dynamically link against the libcuda.so that is shipped or installed with the driver. I don't know if that makes sense. Maybe I can rephrase it in a different way.
I think in a nutshell, correct me if I'm wrong, probably is that an application requires a .so, and the version of the .so is dependent on the driver that is installed on the host,
right? Because
the driver is dependent on the hardware that is installed. So if you move to a new hardware, you need to probably link to a different SO, a different version of the SO, which means you can't take your SOs along.
Yeah, which means that you can't ship the libcuda.so inside a container. Other problems are usually linked to we need to inject some IPCs inside the container. So we have something that is commonly known as NVIDIA persistency. It keeps a context open on the driver, which allows the driver to keep being loaded out at all time inside Linux kernel, and so prevents any costs of reloading the driver whenever you start going into CUDA. And in general, there's all these small little things are related to just mounting files inside the container, mounting IPCs, mounting device nodes inside the container. And of course, once you've started mounting things inside the container, your LD cache is not going to have these libraries inside the container. So what we go ahead and do is that we are going to re-execute ldconfig. So a few years ago, we started with NVIDIA Docker v10, which was a wrapper around the Docker CLI, and we would actually just inject these libraries from the host. We would actually inject these IPC device nodes from the host. That led to a lot of trouble supporting our customers because people don't. So we have a lot of we had to do a lot of changes inside the container images. So for example, we had to actually make sure that the LD library path would point to the right path, and some of the problems that are associated with it is that this variable does not get respected by say UID binaries. So just doing a wrapper around the CLI is not the greatest way of doing things. I think one of the bigger pain point is that we can't really integrate with all the container runtimes out there. We can't really integrate with Podman, with Docker, with Containerd, if we're at a wrapper around the CLI. And so the pre-start hooks felt like a more natural way for us to do things in a way that is scalable, meaning that if there is a new runtime or someone that is going to use runc or use a NoCI compliant runtime, it is a lot easier for us to actually integrate with these people. So that's why we basically evolved towards a pre-start hook, which what we do in that pre-start hook is really just mount files, mount IPCs, mount device nodes, mount procfs, or a subset of the procfs where proc/blocks/driver/NVIDIA, and execute the ldconfig inside the container. So that's the general gist of what we do inside our pre-start hook and why we need to do all these things. Is there any question at this point on what I explained?
Is there anything specific to that you can do with like a base image and just say every NVIDIA container inherits from this base image, which already specifies these implicit like volumes that we're going to mount from the host?
So what you'd be suggesting is we provide a base image per driver version where all these libcuda.sos are actually part of the libcuda.so?
Yeah, potentially. And then you specify volumes for where you would mount the actual like host files as well then in that. So then you know if you have any image that inherits from this base image, you know that it has these volumes that are typical for mounting any like GPU accelerated workload.
If I understood that, that reduces the application complexity. You will have an application derived from a base, which is different for every driver that we have, every hardware that we have. And so you would have an application also saying application container and version X for that hardware, version Y for that hardware, and version Z for that hardware. That hardly makes it a container, Container would that be, well, I have everything in it. It doesn't matter where I'm running, I'll run just fine. But good point, though. I mean, there was probably, unfortunately, in this situation, it doesn't lead it to that solution. Yeah, it'll be stuck.
And was I misunderstanding when you were saying how it's not the binaries are not portable and it's even related to what's loaded in the kernel? Are you saying that these restart hooks would be effectively enforcing whether or not the container could even restart, or is they're just trying to do cleanup and tear down?
If we take a CUDA binary, which is actually just like a normal Linux binary, and we move it from one machine to another, the general guidelines that we give to people who are building these binaries is dynamically load against libcuda. And if they dynamically load against libcuda, then their application will be able to start, because we do have backwards compatibility guarantee, meaning that if you build against libcuda 400 and you go on libcuda 410, if you build against a driver that is 400 and link against a driver, run against a driver that is 400, and then now move your binary to a machine that is 410, then as long as you keep linking against libcuda, then things are going to work out. The problem is really just making sure that you link against a libcuda that has version 410, which is the version that your driver is actually running. Does that make sense?
I guess I'm trying to figure out how it is that, so the hooks you're needing to be able to mutate.
I need to be able to mount files from the host inside the container, mount IPCs from the host inside the container, and then mount device nodes, because we also have some control device nodes that are common, dev NVIDIA CTL. But we do have device nodes that are really just like dev NVIDIA 0 usually matches your GPU 0.
So what is it in Alexa's proposals that doesn't satisfy?
The general gist of the pre-start hook is that right now they are invoked before a pivot root. And the way this is defined currently in the OCI spec is something that would, so the way this is defined in the OCI spec is the pre-start hooks must be called after the start operation is called, but before the user specified program command is executed. And the second part of that definition is on Linux, for example, they are called after the container namespaces are created. So they provide an opportunity to customize the container. So the problem of moving it as part of the start command is that this would happen after the pivot root, which would basically cut us from the, we wouldn't be able to actually have access to the host anymore. And so we wouldn't be able to mount anything inside the host anymore. And I think one of the discussion we were having is that the way that the pre-start hook in runc has been implemented is very similar to the one in LXC. Because it is very useful to be able to have access to the host at this point or as a pre-start hook. Once you only have access to the container, then the number of things that you can do inside the container becomes a lot more limited.
Would it make sense to show this diagram maybe? That helps.
Maybe.
Hey, we just drew a diagram.
I've got it pretty well. I'm just.
It's going to be reversed.
Trying to narrow down. Let me make your view bigger. Yeah. But I think the crux of it is, like you said, that it's inside the container and it loses access to the host. And I think the biggest issue with this is that it's going to be a breaking change either way unless we added a completely distinct hook, like pre-start that includes the host and then pre-start inside the container. Because anybody that's already relying on the expectation that you're inside the container would get broken. And I feel like the only, in my mind, the only way forward would be actually just to make that a distinct hook step. I'm having a hard time hearing you.
Here's the solution that we're proposing. Is it better?
A little bit.
Yeah, okay. So the solution that we are proposing is that the easiest would be the way it is implemented in runc is good. We're working well with it. Nobody has complained so far on how the hooks are being executed by anybody, not just us. We're using it. There may be some non-vocal users also. We probably need to modify the spec itself to be a little more clear that when is it exactly when the start hook is going to be executed. Can we make it clear that it would be executed before the pivot root is executed? If we make that clarification come out clear in the spec, then the implementation just kind of follows it and nobody's affected. If anybody was expecting that the hook should be actually executed after pivot root, they're not still affected, because even if it's executed before it, there you actually have more powers now, so you're not occluded from doing anything that you would get able to otherwise.
Unless your isolation is not just a namespace. If it's a virtual machine or anything else, then that whole thing is torpedoed. Though I think that making it explicit and clear, saying host versus inside the container, would make it nicer anyway, so that way it is a bit more explicit. Because if you're not using a shared kernel, for example, or you have a different user space for the container versus on the host, you could leverage it that, or at least you could be more explicit for it. And to me, it seems like you could use your proposal and just also take Vincent's advice and say, just add a more explicit name.
Are you suggesting that we create another hook which does what it is doing, but just call it another name, because that would probably match what it is? Right now, it gets executed before pivot root, and it's called pre-start. So it is clearly a mismatch between what the spec says and what the implementation is. So we're saying, let's fix the spec because nobody's complaining about the implementation. And if we are going to be, like Eric says, we need to be really strict on, which it should not be called a pre-start hook, then all we could just then do is then call it another name as well. But I would insist, pre-start is probably okay as long as the explanation is clear enough, saying, we're calling it pre-start. What we really mean is we are actually doing it even before the pivot root is executed. And if we make that clear in the spec, the implementation is happy, nobody's complaining so far, nobody has any more demands on how it should be done. And this totally be matching the implementation and we'll be all happy. If there is another need that, hey, can I also have another hook which need be executed after the should happen or the pivot root happens, then we can introduce another hook later on. And adding more hooks or adding something to the spec is much easier than the current situation where we have to kind of modify what it is.
So what of this assumption does Kata containers rely on? Which direction of this behavior, Eric?
I don't have a good answer right now for that. I'm not sure. I have to do my homework, which is unfortunate to come in and say I don't like something and not have a good solution. I'm not sure exactly, in the create versus start phase this happens.
So I believe the way, sorry to cut you, Eric, but I believe the way that we've implemented GPU support in Kata containers with pre-start hook works out in a way that we expect. So I think it works really very similarly to runc. Does that help answer some of that question?
Where does it happen in runc as far as the actual OCI commands where the pre-start hook is executed?
As part of, let me check.
During create phase or during the start?
I believe it's in the create phase.
Okay.
Is it here? It's in the run. I use runc run, so it should be in the. Yeah, it's in the run command. Yeah.
Okay, so just to move forward then. So long as Eric's concern is satisfied, then are we okay with rephrasing or rewording the spec?
So if it, since that's the way that runc does it, and that's the current expectation, especially not just that the current spec is not lining up with the way runc does it, and the runc current implementation is more intuitive and lines up with something like LXC. It would be my inclination to clean up the spec wording just to say this is happening before the pivot route, or shroot pivot route, but pivot route. And if Alexa and W King is kind of fallen off the face of the earth, but if Alexa has such strong feelings that it should be hooks happening within the container's isolation, but before the exec has happened, or entry point, whatever, then that seems like a distinct place, and especially since that effectively would have to be created for the current runc implementation, that would be like net new logic. So that should,
which is fair, I mean, we're not saying Alexa's point would be not a valid point.
Right. And he has plenty of soapboxes to spare, but they're often very valid points.
So in that case, so let's go with what we feel inclined towards. Let's change the spec and clarify what the spec should mean in terms of what it actually matches. So long as Eric's concerns are also met, that in cutoff, for example, we have matching behavior.
Maybe to build on what Rajat was saying, since Alexa is not here and it seems like he might have some concerns, we can summarize this discussion by email, make sure that we have his, make him like a stakeholder of this decision, and then after that, probably reconvene at the next OCI meeting.
It might even be able to happen online beforehand. Yeah, I think that's fun. So now I'll get this posted as a video link, which is interesting. Not that many people ever go back and watch meeting notes, but we have the notes here on the HackMD. Will you Renaud or Rajat do that summary email with to the list?
Definitely. I mean, we're more than happy to help drive this discussion.
Yeah,
has of course a pretty huge impact on our solutions. So
surely, and as far as my understanding goes, it is the only thing holding up the one runc final. But obviously, it's important enough that we've just literally let it linger for years.
So I'll take the action item to write this down and maybe rewrite a bit more what I've mentioned in terms of what are our problems that we're facing with the pre-start hook. And definitely, I think continuing this conversation online should help drive or arrive to a solution.
I'll add my claim on here that this. Yeah, I'll add a few notes real quick.
We might want to add, and then the concerns that we're getting he might disagree. But if he makes those concerns that it should be made inside the container, then of course there's more code, and we should bring about these points. What happens if we heed to the very valid concerns that he might have? What is the way forward then?
Well, the update to the spec, the biggest challenge that I see on that is that gets into the slippery slope of if somebody has implemented 1.0 and this is now considered a breaking change for 1.1, to become a 1.1, and somebody becomes compliant with a spec, 1.0, not the changed in wording, even though runc is not technically lined up with its own 1.0. The reconciliation, even though to me it sounds like this would be as easy as changing that wording to clarify. If somebody wants to go down the path of what is a breaking change and what isn't a breaking change as far as the wording of the spec goes, regardless of runc, that it would be something like pre-start host or some other kind of name that is very clearly on the host, and the pre-start behavior inside the container stays and gets changed within runc. But then it becomes a versioning nightmare of where all that is run. So there's going to be some kind of conversation of which is the lesser of evils there. Changing the expectation of if there's a pre-start host hook available, then use it. Otherwise, fall back to pre-start and the version matrix hell of that, or just actually change the spec and it's looks like a breaking change as far as the wording of the spec goes. That's the biggest hang up that I see in those two.
Well, that might be inevitable. If we,
Surely.
Either we worry and take care of the backward compatibility issues with the spec, or we worry about the backward compatibility and deprecation aspects of runc implementation. Both ways, we'll have to go down that path. Either which way. Okay. True. I think enough good discussion about this. So we'll write the email.
Yep.
Thank you very much.
Yeah. No, I'm glad that it's a discussion point. So thanks for that. I'm going to finish typing in a few notes of this, and then let's see, version. Yeah, and then so Vanessa, it looks like you're on the call. Are you willing and able to chat about your scientific file system? And I will listen for a minute, and I'd hope somebody can type notes as you're talking while I finish.
First, I guess it makes sense to ask a question is, I basically want to make a proposal to add a specification for something called the scientific file system to OCI. It's a spec, it's a published paper, it's implemented in Singularity, it has a couple of client libraries. I think it might make sense to first talk about like what are the actual steps for doing that. I've never done it before. As far as I know, I just open up an issue and then a pull request on a GitHub board. But is this something that we would need more people on the call here, or is a small number of people so can anyone talk about that process that you go through to do a proposal?
So this is a pretty small group of people for that. And usually
send an email.
Also. Yeah, an email, and I think you already raised the issue once there, but the process officially is the TOB, and I think it's just TOB at opencontainers.org is an email there, but there's also the repo, which probably could be a PR. And so any new projects are voted on by the TOB or discussed and voted on by the TOB. Usually it's been pretty narrow enough that we don't have such criteria, even like CNCF, to where they want to see how does this improve the cloud native ecosystem, that kind of stuff. It's usually been such a already intimate, the people involved are already so familiar with this is how, registries or runtime or image format that it makes sense. That there's not criteria for why the donation of this thing or the new project needs to exist. But the process is officially open the conversation with the TOB of why this makes sense, and eventually they'll have a vote eventually being when they see that this is a decision to make.
So would it make sense to kind of poke everyone possibly before the next meeting and then give them a chance to ask questions? And should that be done all over email, or should we do this on the call, or is there no rule at all and I can do whatever I want?
Largely, there's not a strict rule, I think. Most of those folks from the TOB do not do anything unless provoked. I mean, like some of the folks I don't.
I need to make them angry. I need to make everyone really angry.
That's technically their role, is like new projects or otherwise, and dispute resolution. I mean, our founding people were folks like Greg K.H., who's like the stable branch kernel maintainer. Like, he never joined anything. So he never attended any of the calls. Only when we got to a vote, and he ended up being like a private email discussion among the TOB of like what folks think, and we'd vote. So yeah, there's not a very strict process here, but that's the process.
Okay, I'll probably send out another email when I do a little more work on the Golang library, and then get everyone voting. So we don't have to discuss anymore today. I'm done.
Okay, but so is it something though that is you said it was involved in the Singularity project, but is it, how come you see OCI would be a good home for it though?
Well, the base of it is actually a specification. So it's a specification for organization and interaction for sort of modules in a container. Our basic understanding of containers is like you have this unit and it does this one thing, but at least for the scientific purpose, usually if you're running some genomic thing, you're putting a million different executables in the container. In fact, you want to be able to interact with the container and inspect unique environments and have different entry points, different metadata. And so it defines a way to do that. So the original thing was a specification. The specification was implemented, though, natively into Singularity. So you could say that Singularity implements the scientific file system. You can put little snippets in your Singularity recipe and get that. But then, of course, you can also have different clients. So the first thing I made was a Python client that would let you install it anywhere. And because now everyone likes Golang and nobody likes Python, I'm doing it again in Golang. So it's a specification that belongs with the OCI because it really, so in the paper I wrote, the reviewers were upset that I said that it was for containers. And they said, well, you should say that it can be anywhere. You could technically install on your host, but really it's something that I made for containers to have this discoverability and ability to find this container out in the wild that you have no idea what's in it, and then immediately figure out the applications and the environment and all that sort of thing. So something that probably not, I mean, people are aware of, but it's something that not enough people are, trying to develop things for, to make containers less like these black boxes and more like spitting out their guts and like telling you what's inside them.
Mm-hmm. Semantic web for compute units. Okay, that makes more sense now. Okay, so yes, but for sure, if you have work that you're working on it, but also an email to either the list at large to get a feedback loop going, but then also the TOB to actually vote on it, which I don't know how much, like depending on how well or how it's presented, would be either discussion and or just a vote, but for sure. I think it sounds interesting, sounds novel.
Cool, thanks. Yeah, it's useful for science, and I guess I just have to convince people that it's useful for other things too.
Especially for the distribution spec. Feels like it could change the API of the distribution spec. Okay, so there's nothing else added to the agenda for today. So if that's it, I'm going to finish out some notes that I'm thinking of, and then let everybody reclaim 15 minutes. So Thanks for joining, everybody, and I'll see you all online.
Everyone.
Thanks,
Bye.
everyone. See ya.